Hello students, welcome to ePhysics. Students, in this video we will be discussing about Coulomb's law. Now, let's move into the topic. Now, first of all, let's see the statement what Coulomb's law states. It is similar to the Newton's law of gravitation, but over here we only talk about the two charges. In the Newton's law of gravitation, we talk about the two bodies. Here in Coulomb's law, we talk about two charges, okay? So the statement is the magnitude of the electrostatic force between any 2 point charges, okay? We will talk about the point charges, will be directly proportional to the product of the magnitudes of the charges, okay? And inversely proportional to the square of distance between them. The whole of the statement is similar to the statement of Newton's law of gravitation. The only difference over here is the electrostatic force. There we talk about the gravitational force. There we talk about the two bodies. Here we talk about 2 point charges. Otherwise, all the statement, that is the first statement is directly proportional, okay, directly proportional. Next, that is inversely proportional. Now, how will we write it? We will write it as the force is directly proportional to the product of the magnitude of both the charges. Let us consider the 2 point charges are q1 and q2. Okay, let us consider this is equation 1, and the second statement says that it is inversely proportional to the square of distance between them. Let us consider 2 point charges q1 and q2 are separated by a distance r. Okay, now so we can write it as square, okay, r of square of r. So this is equation 2. When we combine both these equations, okay, from equation 1 and 2, from equation 1 and 2, we can get it over here that combinedly the electrostatic force of attraction between 2 point charges is proportional to q1 q2, that is the product of magnitude of the charges divided by r square. If we remove this proportionality sign, we can write it as F equals to K, a proportionality constant, q1 q2 upon r square. Okay, in gravitational force, what we do, we used to take g over here, and that is m1 m2 upon r square. Otherwise, the whole of the statement is similar to that of the gravitational force, that is Newton, that is given by Newton. Okay, so this is the in Coulomb's law. Now here we have different terms, that q1 and q2 are the different charges, r is the distance between the both the charges. Here k is nothing other than the proportionality constant, okay, whose value is equal to, first of all, let me tell one more thing, that it depends on the nature of the medium in which the charges are kept. Okay, so it depends on the nature of the medium in which it is kept. Suppose it is kept in vacuum. In that case, that is for vacuum, or we can say as air. Okay, in that case, the value of k, that is equal to 1 by 4 pi epsilon naught, will be equal to 9, which is somewhere around 8.99, but approximately we used to take it as 9 into 10 to the power 9 Newton meter square per Coulomb square. Okay, and where this epsilon naught is nothing other than absolute permittivity. Absolute permittivity. Okay, permittivity of free space. Whose value, that is epsilon naught, the value of epsilon naught will be equal to 8.854 into 10 to the power minus 12 Coulomb square per Newton per meter square. Here we can also write it as Coulomb square per Newton is Farad. Here we have Farad per meter into F meter or meter inverse, or that is Farad per meter. Okay, so this is the Coulomb's law. So we have seen the statement Coulomb's law, and we have found the formula of it. Here we have seen what is K. We have also seen what is epsilon naught. So we have seen the values as well. Now we will move into the Coulomb's law in vector. Now students, Coulomb's law in vector form. So how will we discuss it? Let us consider we have 2 point charges Q1 and Q2, again separated by a distance. Let us consider R. The force applied on Q1 by Q2, that is force applied on Q1 by Q2 is in this direction, and since the distance is from Q1 to Q2, we will see it as R cap, that is R cap 1 with respect to 2, and the distance of 2 with respect to 1 is in this direction. Therefore the force applied on Q due to point charge 1 is this one, that is F2 due to 1. Now students, if we see, we have the Coulomb's law already discussed, that force is equals to 1 by 4 pi epsilon naught, that is force equals to 1 by 4 pi epsilon naught, the value of K, Q1 Q2 divided by R square. We have this formula already discussed in this video. Now if we only see the magnitude of both the forces, if we remove the direction of the forces, that is force on 1 due to 2, we only see the magnitude will be equal to force on 2 due to the first charge, okay, which can be written as 1 by 4 pi epsilon naught Q1 Q2 upon R square, if we write it in the magnitude form only. Now if we take the direction, if we consider the directions as well, so we can write it as, if the force on 1 with respect to 2 is along, what is the direction of force on 1 due to 2 is along the direction of R cap to 1. We can see it over here, both the directions are same, okay, both are directed towards the left. So is along the direction of R cap to 1, okay. So we can write it as force on 1 due to 2 will be equal to 1 by 4 pi epsilon naught Q1 Q2 upon R square. So the unit vector is R2 1 cap, okay, R cap to 1. So let us consider this is equation 1, and next the force on the second point charge due to the first point charge is along. We can see from the figure that force on second point charge due to the first point charge is along the direction of R cap 1 2. So is along the direction of R cap 1 2. So we can write it as force on 2 with respect to 1 is equals to 1 by 4 pi epsilon naught Q1 Q2 upon R square R cap 1 2. Now students, we can see from the figure that R cap 1 2, okay, R cap 1 2 and R cap 2 1 both are oppositely directed, so we can see from the figure that R cap 2 1 is equal to minus of R cap 1 2. Why the negative sign over here? the negative sign indicates the opposite direction of both the distances. Okay, so we can conclude from equation 1 and 2, from equation 1 and 2 we get that the force on 1 with respect to 2 and the force on 2 with respect to 1, we have seen that the magnitudes are same but are oppositely directed. If they are oppositely directed, then we can say that both the point charges follows or says that every action has equal and opposite reaction. Therefore we can say that it follows the Newton's third law. Okay, Newton's third law. So that's it with the video. I hope you understood it properly. So thank you very much for watching it.